Hello everybody, Root Beer here, and we're going to be looking at the last question on the 2003 Fermat paper put out by the University of Waterloo. That's right, we're up to question number 25. And before I go into reading the question and trying to solve it, and hopefully I can, I'd just like to once again implore you to, if you haven't already, pause the video, download a copy of the contest, and at least try this question for yourself. Okay? Because you can learn so much more just by attempting these questions rather than just watching someone else attempt them. Okay? That said, I'm going to assume you've done that or that you don't care and you just want to see some math done. Let's take a look at question 25. The set 1, 4, and n, I'm going to guess we'll probably have to figure out what n is, has the property that when any two distinct elements are chosen, and 2,112 is added to their product, the result is a perfect square. Any two, so 1 times 4 is 4, 2112 plus 4 is 2116. Is that a perfect square? Square root, just grabbing my calculator because I want to verify that. Ah, it's 46 squared. Nifty. If n is a positive integer, the number of possible values for n is, and then we have 4, 5, 6, 7, and 8. Okay. I can't think of any possibilities off the top of my head. Now, this is a 3-element set, so there should only be 3 possible combinations here. So we have 1, 4, and n. So we could do 2112 plus 1 times 4. And I just said that that's 46 squared. Or we could take 1 and n, assuming that n is not 1 or 4, because I said distinct elements. So we'll have to keep in mind, keep in the back of our heads that probably shouldn't have n is 1 or 4. Anyway. 1 times n, that would be 212 plus n, and we're told that this has the property that it's a perfect square. So let's call it p squared, because I have no idea what square it should be right now. And lastly, we could do 4 times n. And that's also a square, we'll call it q squared. Now, it makes sense since n is positive, then q squared is bigger than p squared. Okay, because there's a difference there of 3n. In fact, I could say q squared, and I could say p squared, so I got 2112 plus 4n. 2112 plus n, and I can take their difference, and then I'm looking at a difference of squares. And these 2112s cancel out, and I'm left with 3n. So the difference of those two squares has to be a multiple of 3, and actually we can factor them, because it's difference of squares. So it's a handy, quick way to factor q minus p times q plus p. That's got to be 3n. Now that's an interesting fact, but I don't like it, and I'll tell you why. I now have 1 equation and 3 unknowns. I've introduced this p, I've introduced this q, and now I've related them to n in some way. Great. But I don't know what n is. I don't have an idea of what n is. All I know is that I have a q squared and p squared, take their difference, divide by 3, that should be n. But I'm no closer to figuring out what n is. That said, if I knew what q and p were, I could use this equation to figure out what n is. Okay? So what I'm actually going to do is do the same technique, line up 2 equations and take their difference, but I'm going to be a bit sneaky about it. So this gave me n's by canceling out these 2,112s. And I'd like to draw your attention first to this equation. I was just going to multiply the bottom one by 4 to get rid of these n's, but I had another idea. This is 4 times, and I know it's a multiple of 4 because the last 2 digits, 12, are a multiple of 4, but I have no idea what multiple of 4 it is. 528 plus n. And this tells me that q squared must be a multiple of 4. And so q is going to have to be an even number because its square is even. Okay? So let's say that q is equal to 2r. So 4r squared is 528 plus n. And I'm going to do this instead of what I was going to do. What I was going to do is I was going to say 4p squared minus q squared, and we'd get some numbers there. So this would be 4 times that. Take their difference, and then these n's would cancel out. But that's gonna leave some big numbers. I think if I do it this way, I might get some smaller numbers. Of course, maybe this will backfire. Maybe I needed to exploit the fact that q is even in some other way or something like that. But I'm liking this, because now what I can do is I can say p squared is clearly bigger. And I can tell you how much bigger, because I can take their difference. So p squared minus r squared is, and what's the difference here? 2112 minus 528. I'm looking at 1584, but now I have no n's. So if I can understand p and r, I can understand p and q, and from there I can get n, at least in theory. So, what are we to do? Well, difference of squares, let's break it up into this. And if we're going to write it like this, we factored the one side. It might be a good idea to break 1584 into its prime factorization. It's got at least a factor of 4 in there. And that gives me 396. That's another factor of 4. So this is 16 times 99. So that's 2 to the 4 times 9. And then an 11 left over. Interesting. So I can say that p minus r times p plus r is 2 to the 4 times 3 squared times 11. So what can we do from here? Well, I don't know. Should I give names to these factors to simplify things? I'm going to call this one... no, let's say... I've been using the latter half of the alphabet. Let's call it S. And this one here will be T. So I've got S times T is 2 to the 4. I don't know if doing this is going to help. I don't know if giving these names is such a good idea. I can always recover P is 2P over 2, which is P minus R plus P plus R all over 2, which is S plus T over 2. And R should be T minus S over 2. So I can recover them. And what to do here? So I've got to split up these factors. And what's catching my eye right now is, in order to recover P and Q, make them integers, which they must be, I have to divide by 2, and I've got some factors of 2 here. So I think S and T both have to be even? Yeah. Okay, the best way to write that Clearly 2 divides 1584, but that's S times T. So 2 divides S or 2 divides T. Okay? One of them, possibly both, but this is a fact because 2 is a prime number. So one of S or T is even. But then let's just say S is even. Okay? Just for the sake of argument. We know P is S plus T over 2. So 2P is S plus T. 2P minus S is equal to T. T is even. So that tells me both S and T are even. Okie dokie. So I'm going to, I guess, write S as 2U and T as 2V. Okay. So, U times V, if I knock off 2 powers of 2, I'm looking at 2 squared times 3 squared times 11. And P is equal to U plus V. And R is equal to V minus U. That simplified some stuff right there. That's not bad at all. Is there anything else I can do? Can I use this factor of 3 in any way? I'm not seeing anything. I suppose I could fiddle around with it a bit more, but I think I'm at a fairly reasonable stage to just start listing out possibilities for U and V. V will, if any pair of factors, V must be the bigger one, otherwise R isn't a positive integer. And I guess looking back on it, I could have done it here, although I wouldn't have wanted to because of this power of 4 here. So we're going to start listing out factors for U and V. And how many factors are there going to be? Well, how many ways can we factor this? To answer that question, we look at the powers that we've got. There's a power of 1 here. We add 1 to each of them. So that's 3 times 2. We should get 18 factors. 18 different ways to do this. Okay? And if it had been a 4 up here, we wouldn't have had 18. We would have had 6 times. We would have had 30, and I don't want to list out 30. Frankly, I'm not that thrilled about writing out 18 of them. But there's not a whole lot to do there. I wish there were a way to reduce it a bit more, but what are you going to do? So, if U is 1, V has got to be 36 times 11, so 396. Okay. Let's make a column for P and for R, and then I guess Q from there. And then if I can work it out as well, N. Because remember, one thing we're trying to avoid is N being 1 or 4, and also can't be negative. And since our possible answers are 8, 7, 6, 5, 4, I'm guessing a bunch of these will have N be not an integer or not a positive integer or something like that. So P is the sum of those two. R is the difference. And Q is, well, it's going to be a pain in the neck to figure out what N is. But Q is twice R. So already I'm grabbing my calculator. I don't like where that's going. Q is 790. Okay. And what was the quick way to get N? P minus Q times P plus Q all divided by 3. I guess. Or was it P? No, it was Q minus P. It had to be because Q was the bigger one. Gosh, I don't like that, but let's figure out what we've got here. 397. So 393 times 397 plus 790. If we divide that by 3, we get n is 155,497. That's a big number. Do I really want to finish this chart is now what I'm thinking about. Is there a way to reduce this even more? Actually, does this number even work? Maybe there's something else I'm not even considering. So 155,497, if I add on 2112, and now I square root it, that's 397. Interesting. And then 155,497 times 4 plus 2112. If I square root that, that's 790. Okay. So this does seem to be working. I'm not going to rock the boat until I maybe notice a pattern. So it'd go 2, 3, 4, 6, 11, 12, I think. So there's going to be 18 factors, but there'll be only 9 pairs of factors. 396 divided by 2. So we get 198. These numbers should be smaller and therefore better to work with. I guess maybe I scared myself off by starting with 396. We'll get 132 here. $99. 396 divided by 6. 66. 396 divided by 11. 36. 396 divided by 12. That'll be 33. I'm missing 22 should be in here somewhere. So I got the 3 and the 33. 22. Oh, I forgot 9. Let's shift all these down by 1. 9 should be 44. And 11 was 36. And 12 was 33. And then we got 22. And 18. I think that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we've got all our possibilities. Now we just need to work out each of them. So P is the sum of those two, so that's 200. And R is the difference of those two, so that's 196. And Q is, we take the 196 and we multiply it by 2. 392. You might say, why are we continuing on? Do we really need to fill out this chart? The math says all this should work. I've got 9 possibilities. 8 is the maximum answer. 8 was A or E or something like that. 8 was one of the answers, and that was the highest one. So at least one of these 9 shouldn't work. I don't know why yet, but I'm betting it's something like n isn't an integer or n isn't positive, something like that, probably. Or maybe n is 1 or 4, in which case, by technicality, I don't think that one should be allowed. Okay, so we're going to have to finish this whole chart. I can't think of a better way to do this right now. And then, so we do Q minus P, 396 minus, so we get 192 times 592, and we divide by 3. So we get n is 37888. running out of room here. 1, 5, 5, 4, 9, 7, 3, 7, 8, 8, 8. Now, to test my theory as to whether or not n will go negative, I'm actually going to skip to the bottom one. So 18 plus 22, that's 40. The difference there is 4. So q is 8. So already I can see there's a problem because we're supposed to take q minus p. And this will be negative. Okay? So we have a bit of a problem there. Out of curiosity, what negative number would that be? 8 minus 40 times 48, divide by 3, negative 512. So if the rest of them all work, we should be set. Let's try 12 and 33. So if we add those two, we get 45. If we take the difference, we get 21. Yep. So 21 times 2, that should be 42. So this is also going to be negative. I'm just going to figure out what n that could be. Negative 87 should do the trick. How about 11 and 36? So if we add those two, we get 47. And if we take the difference, we get 25. Q will have to be 50, so that's looking good. Q minus P is 3. Q plus P is 97. Divide by 3, we get 97 here. So that'll be our n. Let's just double check. N plus 2112. Is that a square? It is the square of 47. Very nice. And I'll assume the other one will work as well. 9 and 44. So we're looking at 53 for their sum. Their difference, 44 minus 9 is 35. So that's 70. 70 minus 53 is 17. Times 70 plus 53 is 2091. Oh, we have to divide by 3, don't we? 697. I wonder if there's a way to prove that n will always be an integer at this point, because it's pretty clear that they're always going to be positive. I'll speak while I finish out this chart. But to make sure that when we divide by 3, we get an integer. That's the key. Now, obviously, we will in this case because everything's a multiple of 3. But let's just work out what n we're dealing with. 48 times 192 divided by 3. This n should be 3072. Okay. 4 and 99, that should be 103. 95 for the difference, and then that's 190 for the sum. 190 minus 103, 87. Hey, that's a multiple of 3. And then we do 190 plus 103. Divide by 3, and I'm getting 8497. And we've got one more to go. I'm pretty sure this one will also work, because I think by now there's probably a proof that q minus p and p plus q, when they're constructed this way, will always be a multiple of 3. So add those two guys there. Actually, yeah, let's stop and take a look at this for a moment. Q will be 2v minus 2u, and p, of course, is u plus v. So if I take the difference there, I'll get v minus 3u. If I take the sum there, I'll get 3v minus u. And when I multiply those together, I'll get 3v squared minus 9uv plus minus uv plus 3u squared. So that'll be 3v squared minus 10uv plus 3u squared. Okay, it's not apparent that that's a multiple of 3. Maybe that's something I'll deal with later. Let's finish up the question. 129 here. 129 multiplied by 2. 258. And then we take the q and we minus the p. Then we multiply it by q plus p. And divide that by 3. 16113. And so we have all the values of n that would work. And it looks like there's going to be 7 of them. And the math says that each n in this column, because those are the equations that we started out with, each of these n's will work, and they are all integers. So there are 7 such n. None of them were 1 or 4, so I didn't need to worry about that at all. And 7 was D, I think, right? No, 7 was B, because they did the reverse order. So that should do it for question number 25, and that actually finishes the whole paper off. Thank you guys for watching. I think what I'm going to do now, and I'm not going to do it on video, but I'm actually going to see if we construct them this way, will we always get n as an integer? That's something I'm going to work on, and that's just for me. That's something I want to try because I saw this in the question. No, I'm not going to get any points for this. I'm not obviously going to get any views for it because I'm not going to record it, but something fun to try. Maybe you guys should try. And I don't really have anything left to say, so yeah. Thanks for watching, and next I guess I'll be doing the grade 11 Hypatia. So that's the written grade 11 contest, and you can look forward to that one. Or, if it's in the future, of course you can just go and click on it, okay, because it'll already be out. So, thanks for watching again. I think that's the 3rd time I've said it, and I'll see you guys in the next video.